Good morning, students. So this class we are going to determine the partial fraction expansion of x of z the whole square z x of z which is equal to 4 divided by 1 plus z power minus 1 into 1 minus z power minus 1 the whole square. It is clear that x of z corresponds to the case 3 which n equal to 3 greater than m at the second order pole at z which is equal to 1. Hence x of z which is equal to x of z is x of z which is equal to a divided by 1 plus z power minus 1 plus c1 divided by 1 minus z power minus 1 plus c2 divided by 1 plus z power minus 1 the whole square. For employing a is a1 which is equal to 4 divided by 1 plus z 1 minus z power minus 1 the whole square, where z which is equal to minus 1 we will get z which is even 1. So that is a, and c1 which is equal to 1 divided by 2 minus 1 into 1 power minus whole squared 2 power minus 1 d by d omega and 1 minus 1 into omega the whole squared 4 divided by 1 plus omega into 1 minus omega the whole square, where omega which is equal to 1. So where d by d omega 4 divided by 1 plus omega, where omega which is equal to 1. Substituting the value of omega in that equation 4 divided by, so 1 plus omega the whole square, where omega which is equal to 1 we get 1. So that is the value of c1, and c2 will be calculated by 1 divided by 2 minus 2 and 1 minus 1 the whole 2 power minus 2 into 1 minus 1 into omega the whole squared 4 divided by 1 plus omega into 1 minus omega the whole square, where omega which is equal to 1, and 4 divided by 1 plus omega where omega which is equal to 1, omega c1 which is equal to 2. Therefore the partial fraction expansion for x of z which is equal to x of z which is equal to 1 divided by 1 plus z power minus 1 plus 1 divided by 1 minus z power minus 1 plus 2 divided by 1 minus z power minus 1 the whole square. And case 4, m greater than or equal to n with multiply order poles. This is a most general case, and the partial fraction expansion x of z is x of z which is equal to summation t which is equal to 0 to m minus 1, where b I z power minus 1 plus summation k which is equal to 1 and k not equal to 1 into n, and ak into 1 divided by ck into z power minus 1 plus summation m which is equal to 1 to k into c power m divided by 1 minus c1 into z power minus 1 the whole power m, assuming that there is only one multiple order pole of order s2 greater than or equal to 2 at s z which is equal to c. It is easily extended to this scenario when there are two or more multiple order poles. In this case 3, the a, k, b, I and c, m can be calculated in the cases 1, 2, 3. And power series expansion, when x of z is expanded in the power series according to x of z which is equal to summation m which is equal to minus infinity plus infinity x of n into z power minus 1 which is equal to x of minus 1 into z power minus 1 plus x of 0 into z power 0 plus x of 1 into z power minus 1 plus x of 2 into z power minus 2 plus and so on. So any particular value of x of 1 can be determined by the finding the coefficient of the appropriate power of and determining x of n which has a transform of the form, and x of z which is equal to 2x squared 2z squared into 1 minus 0.5 into z power minus 1 1 plus z power minus 1 into 1 minus z power minus 1, where modulus of z less than 0 and less than infinity.